This video is on switch port configurations. Just as a network card in a PC can have specific conditions like duplex and speed set, so too can a switch port. When you configure a switch interface, there are often numerous options that you can choose or tweak. First, we have port tagging. A port is a tag port when an interface is expecting frames containing VLAN tags. Tagging is used if you're trunking. Because trunking combines VLANs, you need a way to identify which packets belong to which VLAN. 802.1q tagging allows the port to add 4 byte tag field, which contains the VLAN ID to each packet sent on the port. Then we have port aggregation, which allows you to group multiple physical ports into one unit. Port aggregation is useful for implementing load balancing and provides a redundant link backup. To allow port aggregation, the basic configuration of all the ports must be consistent. Link Aggregation Control Protocol, or LACP, is one element of IEEE specification that provides guidance on the practice of link aggregation for data connections. It's standards-based method to control bundling of several physical network links together to form a logical channel for increased bandwidth and redundancy purposes. Then we have flow control. Ethernet provides means of temporarily stopping the transmission of data to ensure zero packet loss in presence of network congestion. And this is accomplished using flow control and the pause frame. Then we have port mirroring, also known as port spanning. You need some way to monitor network traffic and monitor how well a switch works. Port mirroring copies the traffic from all the ports into a single port, and this allows bidirectional traffic on that port. To use port mirroring, admins configure a copy of all inbound and outbound traffic to go to a certain port. And then a protocol analyzer examines the data sent to that port and therefore does not interrupt the flow of regular traffic. Then we have port security. Port security works at layer 2 of the OSI model and allows admins to configure switch ports so that only certain MAC addresses can use the port. Then we have jumbo frames. One of the biggest issues with networking is that data of various sizes is crammed into packets and sent across a medium. Each time this is done, headers are created along with any fillers needed, creating additional overhead. To get around this, the concept of jumbo frames is used to allow for very large Ethernet frames. And by sending a lot of data at once, the number of packets is reduced and the data sent is less processor intensive. Then we have MDI-X. This technology expands on MDI, medium dependent interface, and enables ports on newer network interfaces to detect if the connection would require a crossover. If it would, then it automatically chooses the configuration needed to match the other end of the link. Other common configuration parameters include speed, whether the duplexing will be used or not, IP addressing, and default gateway. Duplexing determines the direction in which data can flow through the network media. By default, Cisco switches will auto-negotiate the speed and duplex settings. When you connect a device like switch or a router to a port on a Cisco switch, the negotiation process will occur and the devices will agree on the transmission parameters. Full duplex data transmission means that data can be transmitted in both directions on a single carrier at the same time. Half duplex means between two devices, only one device is capable of transmitting and receiving data on a network or bus at one time. If the speed is 10 or 100 megabits per second, you would use half duplex. If the speed is 1000 Mbps or faster, you're gonna use full duplex.